Good day, grade 11s. Welcome to Euclidean geometry. So we're going to do Euclidean geometry and specifically circle geometry. So let's get into it. So we have few terminologies that we need to go through before we can start with the theorems. So the first, we have an arc. So as you can see, an arc is a distance of a curve, right? So it's a curvature. It's a curved portion of a circle. So it's an arc. An arc is a curved portion of a circle. So it's a portion of the circumference of a circle. As you can see here on this diagram, it shows you an arc here. As you can see, this is an arc. It's a curvature. And then the second one, we have a chord. A chord is a straight line joining the ends of an arc, right? So a straight line that joins the ends of an arc is called what? A chord. For example, you can see that we have a chord here. So let me highlight it. So this is a chord, right? And then the definition says is a straight line joining the ends of an arc. The arc that we are referring to is this arc. Can you see? This is the arc. So the chord joins the ends of this arc. So that's a chord. And then we have the circumference. The circumference is the perimeter or the boundary of the circle. As you can see, it is actually the perimeter of the whole circle. The distance around the whole circle is what we call the circumference. And then we have a radius. A radius is just a line from center to what? To the circumference. So the line from center to the circumference is the radius. And then we have the diameter. The diameter is a special chord that passes through the center of the circle. And the diameter is a straight line segment from one point on the circumference to the other, to another point on the circumference that passes through the center of the circle. And a diameter divides the circle into two equal parts. And then we have a segment. A segment is formed. It's part of the circle that is cut off by a chord. So a chord divides a circle into what? Into two segments. And a segment is also basically an area that is formed when a chord and an arc. So the area formed by a chord and an arc is what we call as a segment. So in this case, you can see that this chord and this arc, they form this area here. So this is what we call a segment, basically, right? Then we have a tangent. A tangent is a straight line that makes contact with the circle at only one point on the circumference. So this is the tangent. It's a straight line that will touch the circle at one point. And then there is one that is not mentioned here, which I will mention it for you, is what we call a sector. This is a sector. So this is a sector. A sector, you can think of a sector as sort of a pizza slice. Think of a sector as a pizza slice, and a sector is formed by what? An arc and two radii. So you can see that here we have the radius, we have a radius, and then we have an arc. So they both, two radii and an arc form what we know as a sector, as you can see there. So then these are the definitions that we needed to know, and then now we can get into it. Now we're going to start with Theorem 1. So Theorem 1. Theorem 1 says that the line drawn perpendicular from the center of a circle to a chord bisects the chord, right? So I'm going to now draw a circle here, and then we have let me make the circle much bigger. So we have a circle here, right? And then we have a center. And the theorem says the line drawn perpendicular from the center of the circle. So then I'll draw a chord here, which I will call AB, right? And then my center is O. And then the line drawn perpendicular from the center of the circle to a chord. So I'm going to draw a line drawn from the circle center that is perpendicular to the chord, because that's what the statement is saying. And then it says what? That line bisects the chord. So that's the theorem. It means here we want to prove. So I'm going to put a P here. So that means we are required to prove what? So if we translate the theorem statement into a mathematical symbols, what does that mean? It means that if OP is perpendicular to AB, then AP is equals to BP. So that's what it means. So bisect means divide into two equal parts. So that's what bisect means. So it means we are given that OP is perpendicular to AB. So we want to prove what? We want to prove that AP is equals to BP, right? Given OP perpendicular to AB. Then we start with the proof. So then here is the proof. So when we prove, the first thing that we do, we're going to construct. So we're going to construct AO and BO. So then we can do our construction. This is our construction. And then after constructing, then we're going to say in triangle APO and triangle BPO, right? And then now we're going to say AO is equals to OB. Reason? So we can see that AO and OB are what? They are radiuses. So the reason here will be radii. They are radii. So we know that the radius of a circle are equal. So the radii of a circle, they have the same length, right? And then the next we're gonna say OP is equals to OP, and then reason will be what? Common side. It's a common side that the two triangles share, right? And then now we're going to say that we're going to say what? So we can see that OP is perpendicular to AB, right? So then we can say that angle APO is equals to angle BPO, and then reason they are both 90. This is because is given that AOP is perpendicular to AB. Because of it's given that AOP is perpendicular to AB, so we know that the angle here is gonna be 90 also, right? And then now we can show that, okay, AO represents the hypotenuse, right? Because we are dealing with right angle triangles. So the triangles that we are dealing with here, they are right angle triangles, right? So we have the hypotenuse, and then we have a side, and then we have what? A right angle. And then once we have this, then we can make a conclusion and say what? And say therefore triangle APO is congruent to triangle BPO, and then the reason will be what? RHS, which stands for right angle hypotenuse side. This is one of the conditions for what? For congruency, right? And then remember, congruent means that the two triangles, they have the same measurements, their angles are the same, their corresponding sides are the same. That's what congruent means, right? It means their corresponding angles and corresponding sides are the same, right? Then now that we know that they are congruent, then we can say what? We can say therefore AP is equals to BP, and then the reason will be triangle, our reason will be triangle APO is congruent to triangle BPO. So this will be our reason, and then we have proved the theorem. So therefore theorem 1 proved. And then when we apply the theorem in problems, we have to write it in a shorter manner. So we have a short version of this theorem statements when we apply it in problems. So I'm going to write it down so that you can remember how to write the reasons when we apply the theorem in problems. So this is how you will write the reason when you apply the theorem in problems, right? So short application. So for application purposes, so I'm just gonna so the reason that you will write when you apply the theorem, you will say perpendicular from center bisect chord. So this is the reason you will give when you apply the theorem, right? So that's how you will write the reason. So we have proved the theorem now. So next we have the converse of the theorem. Yeah. So let's talk about the converse. So a theorem says this. Let me show you. So this is what a theorem will say. So a theorem basically says if P then Q, right? So P stands for whatever that statements that we are given, and Q stands for the results that come out. So, and then this will be the converse. So the converse will be the reverse. If Q then P. So this will be the converse. So this will be the converse. So if we look at the statement, the converse of the statement of theorem 1, it says what? The line segment joining the center of a circle to the midpoint of a chord is perpendicular to the chord, right? So we know that in the previous, when we were proving theorem 1, the theorem 1 states what? Theorem 1 says, so theorem 1 says if Theorem 1 states that if if OP is perpendicular to AB, right, then AP is equals to BP. So the converse of theorem 1 will say, so the converse theorem 1, so the converse of theorem 1, it will be the opposite. It will be if AP is equals to BP, then OP is perpendicular to AB. So this is what the converse will say. And you see, so the converse is basically the opposite. Yeah. So these are if and if statements, if and only if statements. So now we can get into it and talk about the converse. So I have the same cycle, and then I have a center O, and I have a chord, right? And then in this case, I know that we have APB, right? And then here, the converse says what? If AP is equals to BP, meaning we know that this AP is equals to BP, right? So then OP is perpendicular to AB, meaning here we are required to prove that OP is perpendicular to AB. So that's what we are required to prove. So the same thing, we're going to do construction, right? So we do construction. So first step, we're gonna do construct OA and OB. So when we do that, we will just construct, and then we do the same reasoning. We're gonna say AO is equals to OB, and then it will be radii, and then we have OP is equals to OP, reason, common side for both, and then also we have to state here that we are dealing with in triangle APO and triangle BPO. We have to specify, and then now we have AP is equals to BP. This one is given, right? And then now we can say what? And then now we can say, we can see that we have a situation where we have a side. Remember, we don't know that this triangle is a right angle triangle, so we just say side, and then we say side, we have side, and then we say side, since we don't know what type of a triangle is this, right? And then now we can say, and therefore triangle APO is congruent to triangle BPO, and the reason will be side, side, side. And then now, because the two triangles are congruent, it means they have the same measurements. It means their corresponding angles and sides are equal, right? So then we can say that angle APO, so angle APO is equals to angle BPO. So angle APO is this one. So we have angle APO. So I'll just color it here so you can see it. So APO is the red angle, is this one, is equals to angle BPO is this one. So this is BPO, angle BPO. So they are equal, and the reason why they are equal is because of what? Is because of triangle APO is congruent to triangle BPO. And then now what happens? We're going to say angle APO plus angle BPO equals to 180, and reason they are angles on a straight line. Angles on a straight line. And then, but angle APO is equals to angle BPO. So where we see angle BPO, we can replace it with APO. So we'll have angle APO plus angle APO is equals to 180, and then reason will be what? APO is equals to BPO. And then now we can say APO plus APO, they are like terms, so we'll get what? We'll get 2APO equals to 180, and then we divide both sides by 2, and then we see that angle APO is equals to what? 180 divided by 2 is 90, right? Yeah, it's 90. So here we don't know that they are right angles. Let me just show that we don't know, because if we put right angles, it means we are now sure. So we don't know yet that they are right angles. So we can now see that actually it's a 90-degree angle, right? So the angle is a 90-degree angle. Here we can see, so we have a 90-degree angle. So then we can make a conclusion. That therefore it means that OP is perpendicular to AB. So then we have proved the converse of theorem 1. And then next we have few examples that we are going to do. We have example 1, which says given OQ is perpendicular to PR and units, and we see that OP is equals to 5 units. We see that OP is equals to 5 units. Yeah, so OQ is perpendicular to PR, and we are supposed to have PR is supposed to be 8 units, right? And then we can see that OP is 5 units. And then we are told that OQ is perpendicular to PR, right? So then we know, because of its perpendicular, according to theorem 1, if the line from center, which is OQ, is perpendicular to a chord PR, it means it bisects the chord, right? So then we can say that PQ is equals to RQ, reason perpendicular from center bisects chord. Because we are told that the line from center is perpendicular to the chord, right? Perpendicular from center bisect chord. And then because PR is equals to 8 units, it means what? It means PQ is equals to RQ is equals to 4 units, right? So we will have 4 here. We'll have 4 there. And then now we can now use the Pythagoras theorem, because of triangle PQO is a right angle triangle. So then we're gonna say in triangle PQO, right? And then we'll have PO squared is equals to PQ squared plus QO squared. Reason Pythagoras theorem. And then what is PO? PO is 5. Then we'll have 5 squared is equals to 4 squared, which is PQ, plus QO, which is x squared. And then 5 squared is 25. And then 4 squared is 16 plus x squared. And then 25 minus 16 is equals to x squared. And 25 minus 16 is 9 equals to x squared. Then we have x squared is equals to 9. And then we take the square root both sides. And then we'll have plus minus, then we have x equals to plus minus 3, but we take only the positive part because we are dealing with length, right? So that means the correct answer here is x is equals to 3 units. So we are interested with the positive answer since we are dealing with length and distance, right? So then x is equals to 3 units. And then example 2, we have what? In the circle O, you are given the length of the chord GP is 6 units, and the OC is equals to 1. Also, OC is perpendicular to GP at point C. Determine the length of OF. So again, you're gonna say GC is equals to PC. Reason: perpendicular from center bisects chord. Because we can see that the line from the center, which is line OC, is perpendicular to chord GP. So it means it divides chord GP into 2 equal parts. That's what it means. And it divides it into 2 equal parts at what? At point C. So it's very important to note that. So it means we have that situation. And then because we are told that GP is equals to 6, which is given, so it means GC is equals to PC is equals to 3, basically. So then now we know that we have a 3 here, and we also have a 3 for PC, right? And then now we are looking forward. Now we want to determine the length of OF, right? We want to determine the length of OF, but we are told that OC is equals to 1. So OC is equals to 1 is given. So this is 1. So, and then now we're going to say construct GO. So then we can construct GO. And then after constructing GO, we're gonna say in triangle GCO. And then we can see that it's a right angle triangle, right? So we can use the Pythagoras theorem. So the hypotenuse is GO because it's facing 90-degree angle. So GO squared is equals to GC squared plus OC squared. Then what is GO squared? It's what we are looking for. So we have GO squared is equals to GC squared is 1. So we'll have 1 squared plus, no, GC squared is 3. So we'll have 3 squared plus OC squared, which will be 1 squared. And then GO squared is equals to 3 squared is 9, and then 1 squared is 1. And then GO squared is equals to 9 plus 1 is 10. Then we have GO squared is 10, and then we take the square root both sides. We always take the positive value, so GO is gonna be 10 units. Sorry, the square root of 10. So GO will be the square root of 10. But GO is a radius, right? So you can see that GO is equals to OF. Both are what? They are radii. So it means that the square root of 10 is equals to OF, which is what we are looking for. Therefore, we can conclude that OF is equals to the square root of 10. And if they want an answer by decimal form, you can just change it into decimal form, right? So then this is how we solve this problem. So next we have example 3. Example 3 says that A, B, and C are points on the circle having a center O. S and T are points on AB and AC respectively, such that OS is perpendicular to AC and OT is perpendicular to AB. And we are given that AB is 40 and AC is 48. And then we are told calculate AF. calculate AS. You want AS, so it's easy. We can just say CS is equals to AS. Reason, perpendicular from center, bisect chord. So if a line is perpendicular to a chord at some point on the chord, then it divides the chord into two equal parts at that point where it is perpendicular to the chord. So then we know, since we are given that AC is equals to 48, right? So it means that CS is equals to AS is equals to what? Is equals to 24. Because of 24 plus 24 is 48. So therefore we can conclude that AS is equals to 24 units. So then we know that we have 24 here, we have 24 there. Then we are told that if OS is 7 over 15 OT, calculate the radius of OA. So calculate the radius OA of the circle. So we have 24, and then we are also told, so the other information that we have is that AT is equals to BT, resin, perpendicular from center, bisects chord, right? And then we are told that AB is equals to 40. This is given, and here also is as given. And then it means that AT is equals to BT is equals to 20. So we have 20 here, and then we have 20 here, right? And then now we can say that in triangle OSA, we have what? We have OA squared is equals to OS squared plus AS squared, and then we know it's Pythagoras theorem, right? And then we know OA is equal, we don't know OA, and then we know OS we are told it's 7 over 15 OT. So we are told it's 7 over 15 OT, so we're gonna write 7 over 15 OT all squared plus AS is 24 squared, right? And then we have OA squared is equals to, then 7 squared is 49, and then 15 squared is 225. Then we have OT squared plus 24 squared. 24 squared is how much? 24 times 24 is 576. And then we have this situation. And then now we're gonna say in triangle OAT, we're gonna have OA squared is equals to OT squared plus AT squared. And then we can take this further to this, and then we say OA squared, we don't know it, and then OT squared we also don't know, but we know AT is 20, so we'll have 20 squared, so OA squared is equals to OT squared plus 400, right? And then the goal is to calculate OA, right? So it means I'm going to make OT squared the subject of the formula, and then when I do that, I'll have OA squared minus 400 is equals to OT squared. So then I'll call this one here to be equation 1, and then this one I'll call it equation 2. Then I'm gonna say substitute equation 2 into equation 1. So where I see OT squared, I'm gonna replace it with OA squared minus 400. So we have OA squared is equals to 49 over 225. And then where I see OT squared, I just replace it with OA squared minus 400 plus 576. Then OA squared is equals to 49 times that will give us 49 over 225 OA squared minus 49 times 49 over 225. 49 over 225 times 400 will give us 784 over 9 plus 576. And then we're gonna say OA squared minus 49 over 225 OA squared is equals to minus 784 over 9 plus 576. And then I'm going to take this calculation on that space right there. So then we have OA squared minus 49 over 225 OA squared is equals to, and then now we're going to calculate negative 784 divided by 9, and then we add 576, we will get 4,400 divided by 9. So if we get 4,400 divided by 9, and then here we have OA squared minus 49 is the same as saying 1 minus 49 over 225. So we'll have 1 minus 49 over 225, and then we have 176 over 225 OA squared is equals to 4,400 over 9. And then after this, we can divide both sides by 176 over 225. So then we'll have, when we divide, we have to put it inside brackets. It's very important. So we'll have 225, because I'll put also this one in brackets to make sure that the calculation is accurate. Put it, then this cancels this, and then we are left with OA squared equals to, and then now we can find the answer to that. So then we'll have 4,400 over 9 over 9 divided by 176 over 225. Then we get 625. So we get 625, and then now we can find the square root both sides. We are interested in the positive value because we are dealing with distances and length, right? So equals to, then the square root of 625 is equals to 25. So OA is 25. So then we have found the value of OA is 25. So this calculation extends there. Yeah. And then now this is how we solve the problem. And then next we have example 4. It says that in the circle with center O, OQ is perpendicular to PR. OQ is perpendicular to PR, so we know that here is 90 degrees, right? And then PR is equals to 12 units and SQ is equals to 2 units. Determine the value of X. So the moment we are told that OQ is perpendicular to PR, then we know that PS is equals to RS, and then reason will be perpendicular from center bisects chord, right? Perpendicular from center bisect chord. So it means that since we are given that PR is 12 units, it means that PS is equals to RS is equals to 6 units. So then we know that here we have 6 and here we have 6, and then we are told that SQ is 2 units. So we can just write 2 there, right? But we also know something. We know that PO is equals to OQ. Radii. The reason is because of radii. So it means we know that since PO is X, then we know that OQ is made of QS plus SO. And then we know that QS is given as 2. So we have 2 plus SO. And then we can take 2 to the other side, and then we have X minus 2 is equals to SO. And therefore we can say SO is equals to X minus 2. Then we can write X minus 2 here. And then now we're going to say in triangle PSO, and then this is the right angle triangle that we are dealing with. We have S, we have O, we have P, and we have X here. We have X minus 2 here. We have 6 here. Then because it's a right angle triangle, we can use the Pythagoras theorem. The hypotenuse is the side facing the 90-degree angle, so we have PO squared is equals to SO squared plus PS squared, and then reason will be the Pythagoras theorem, and then PO is gonna be X squared is equals to SO is X minus 2 all squared plus PS is 6 squared. Then we have X squared is equals to, when we expand this, we have X minus 2 plus 6 squared is 36, and then you have X squared is equals to X times X is X squared, X times minus 2 is minus 2X, so this times this, and then this times this, and then now this times this is minus 2X, and then negative 2 times negative 2 is positive 4 plus 36, and then we have X squared is equals to X squared minus 2x is minus 4x plus 4 plus 36 is 40. And then we can see that x, when we take x squared minus x squared is equals to minus 4x plus 40. X squared minus x squared is 0, so they will cancel. We'll get 0 is equals to minus 4x plus 40, and negative 4x, when it goes to the other side, it becomes positive 4x is equals to 40, and then we divide both sides by 4, and then we'll have x is equals to 40 divided by 4 is 10. So then the value of x is going to be 10. So this is how we determine this unknown variable x. And then now we have example 5, which says that in the circle with center O, OT is perpendicular to SQ, and OT is perpendicular to PR, and OP is 10 units, and ST is 5 units, and PU is 8 units, and we want to determine the value of TU. Then we're gonna say gonna start by saying let tu be x. So then I'm gonna put x here so that it can make things. So by letting tu to be x, we are going to, it will make the mathematics more simpler for us to deal with, right? And then now we can use the information that we have. So let's see, what do we have, right? So we want tu basically, which represents x, right? So we know that OP is equals to OV. Reason, their radius. It's because of they are radius, right? And then we also know that we are given what? Let's see. We are not given TV. So since we are not given TV, it's not going to help us to know that this is perpendicular. To know that OP is equals to OV, how will that help us? So it won't help us basically. But we know also, let's just write what we know. So OP is also equals to OQ. We'll find out whether it will help us or not. So it's also radii. So it means we know is 10. OQ is also 10. So OQ is 10 units. And also OV is also 10 units. So OV is also 10 units. Right? Yeah. So OV is also 10 units. Then let's see. So we can find, then we're going to say in triangle POU. You can see that in triangle POU we have this situation where we have a right angle triangle OUP. Can you see? So it means the statement OP is equals to OV is definitely going to help us. So now we have 8 units here and then we have 10 units here. We're going to look for UO. So to look for UO, then we use Pythagoras theorem. And when we use the Pythagoras theorem, then we're going to have OP squared is equals to UO squared plus UP squared. And then reason Pythagoras. And then OP is 10 squared, UO is what we are looking for, and UP is 8 squared. And then 10 squared is 100 is equals to UO squared plus 64, and then 100 minus 64 is equals to UO squared. And then we have 100 minus 64 is equals to 36. And then when we take the square root both sides, and therefore we will get that UO is equals to 6. The square root of 36 is 6. So then we have a 6 here. Let me use a different color so that you can see it. So we have a 6 there, right? So UO is 6. But we just showed that OV is equals to 10 units, right? This one we just proved it, right? So then we can say that TU plus UO. So but this is not going to help us. Let me not include it. Let me remove this. It's not going to help us. So let's put things that are going to help us, right? So now we see that we are told that OT is perpendicular to SQ, right? So it means what? It means we have this situation. So it means we have this situation here. Let me show you the situation. So we have that ST is equals to TQ. and reason here will be perpendicular from center, bisect chord, because we are told that this line from center here is perpendicular to this chord right here. You can see that, right? So it means if it's 5 there, it's gonna be 5. We'll have a 5 also there. So it means then we have that TQ is also 5. So TQ is 5, and then OQ is equals to 10. This one was proved, right? Therefore, we can now say that OT. So OT, we can see. So then we're going to say in triangle OTQ, we have, I'm going to draw the triangle so you can see it. And it's a right angle triangle, right? And then we have T, we have O, we have Q. And then we can see here we have 5. And then what is TO? TO is x plus 6. We can see that from TU we have x and from UO we have 6. So when we add both of them, they form TO, which is x plus 6. And then OQ, we just showed that it's 10. And then now we can use Pythagoras theorem to solve for x, right? And then the hypotenuse is OQ because it's the side that is long and it's facing the 90-degree angle. So we're going to say OQ squared is equals to TO squared plus TQ squared. This will be the Pythagoras. And then we have OQ is 10 squared is equals to TO, which is x plus 6 all squared, plus TQ is 5 squared. And then 10 squared is 100. And then we can split this into 2 brackets when we want to expand it. And then 5 squared is 25, and then we have 100 is equals to x times x is x squared, x times 6 is 6x, and 6 times x is another 6x, and then 6 times 6 is plus 36 plus 25. And then we can take the 100 to come. Before it comes, we can just add everything. X squared, 6x plus 6x is 12x, and 36 plus 25 is equals to 61. Then we take 100 to the other side. We have 0 is equals to x squared plus 12x plus 61 minus 100. Then we have 0 is equals to x squared plus 12x, and then 61 minus 100 gives us minus 39. Then when you get to this situation, you can use the quadratic formula or you can factorize. So you can either use the quadratic formula or you can factorize. Any method that will work for you. So you can use the quadratic formula or you can factorize to get the answer to the question, right? So in this case, I'll just use the quadratic formula. So when you're using the quadratic formula, we'll have, the reason why we are using the quadratic formula is because of, if you look at the factors of 39 are 1, right? They are 1, and then we have 3, and then we have 13, and then we have 39. So you can ask yourself, which two factors of 39, when you multiply them and when you add them, they will give you a 12. So you can see that the combination can never work, right? So that's why we have to use the quadratic formula. So if we use the quadratic formula, then we have x is equals to minus b plus minus b squared minus 4ac over 2a. Then we can just substitute here. So we have minus 12 plus minus 12 squared minus 4a is 1, then c is minus 39, and then all over 2 times a, which is 1. And then when we do that, we're going to get two values basically. So we get x is equals to 2.66, or x is equals to, so we'll get two values. We get another value of minus 14.66, so we get minus 14.66 as a value, right? And then because we are dealing with length and distance here, means the correct value is the positive value, right? So the positive value is the correct value, so therefore the positive value, therefore x is equals to 2.66 units. Because x is equals to tu, right? So it means therefore tu must be what? 2.66. So that's what we were looking for. Then our tu is going to be 2.66, as we can see. So our tu is 2.66. And then now we can go on to solve the last question, which is example 6. Example 6 says that in the circle with center O, OT is perpendicular to QP, and OS is perpendicular to PR, and OT is 5 units, PQ is 24, and PR is 25 units. Determine the value of x. So then the same way, we're just going to look at the problem and see what information can help us to find the solution. So already I can see a hint. That can help me to solve the problem, right? And what hint do I see? So I'm gonna first say PT is equals to QT. And reason, perpendicular from center bisects chord. So since we are given that PQ is 24, this is given, right? Means that PT is equals to QT is equals to 12. So it means we have 12 here and then we have 12 here. The reason why is because we are told that OT is perpendicular to QP. So it's theorem 1. Perpendicular from center bisects chord. Very important to remember that. Then now we're going to say in triangle OQT, then in that triangle we are then we have Q here, we have T here, we have O, and we have 5. So we are looking for OQ, and OQ represents what? It represents a radius. So OQ represents a radius. That's what we are looking for. It's gonna help us. Then we can now use the Pythagoras theorem. The longest side, or the hypotenuse, is OQ. So we're going to say OQ squared is equals to OT squared plus TQ squared. Then OQ squared is what we are looking for, and OT squared is 5 squared, and TQ squared is 12 squared. OQ squared is equals to 25 plus 12 squared is 144. And then 25 plus 144 gives us 169. And then the square root of 169 is gonna be 13. So the square root of 169 is 13, so it means we have a 13 there, right? So we have found the radius. The radius is how much? The radius is actually 13, right? And then now that we have found the radius, then we can do a construction. So we're gonna say construct OR. Then I'm going to construct OR here. Then after constructing OR, then we're gonna say that PS is equals to RS, reason perpendicular from center bisects chord, perpendicular from center bisects chord, and then we are given that PR is 25, so it means PS is equals to RS must be what? 12.5, because 12.5 plus 12.5 gives us what? 25. So we're gonna put 12.5 here and 12.5 there. Then now we know that we're gonna say that OQ is equals to OR. They are both radii, and then it means that OR is actually how much? Is 13. So we have 13 here, and then now we're gonna say in triangle OSR, and then the triangle OSR, I'll just draw it here, and this is our right angle triangle. We have X, we have O, we have S, we have R, and then we have 13, we have 12.5. Then the hypotenuse is 13, so we're gonna have OR squared is equals to OS squared plus SR squared. OR is 13 squared, OS is X squared, SR is 12.5 squared. Then 13 squared is 169 is equals to X squared plus 12.5 squared is how much? 12.5 times 12.5 is 156.25, and then we take it to the other side. 169 minus 156.25 is equals to X squared, and therefore we can now have X squared is equals to, and then 169 minus 156.25 will give us 12.75, and then the square root, both sides we are interested in the positive value, so therefore X is gonna be the square root of 12.75 is equals to 3.57. So the value of X is therefore 3.57. Then this is our value of X. So this is how we solve the problem basically. And yeah, and next time we will do the next theorem that follows. So bye for now. See you next time, grade 11s.